Hello, welcome back to Blender Sushi Live Noding. In this video, I'm going to explore this kind of strange Sverchok nodes called vector polar input and vector polar output. There is a documentation provided, and there's also this nodes tree example that you can try. So you could apparently create like a spiral easily using this node, but the magic happens when you actually starting to use multiply and sine and plug into the angle. You will see very soon. You can also use the vector polar output and plug in like 3D mesh and kind of it will turn the 3D objects into I don't know how to explain it, but it's like a maybe into like the dimension of spherical or cylinder. I don't know, but let's quickly have a look. Let's see, where's Blender? Yeah, actually I made this earlier today using the polar thingy. I don't know how I get here, but it's a trial and error, so let's start from the beginning. Make this full screen. File save as vector polar demo. Some of the node in Sverchok is can be quite strange unless you look at it and then you give it a try. We're gonna use the vector polar input mostly, but let's have a look. So if you're looking at the node like this, and then it say okay, it's expecting float input for rho, pi, and z, and if you change to sphere, you have a theta, which is also kind of alien if you first using it, but the output seems to be a vector. So let's have a look at one of these. If I plug these vectors into the vertices, we have a single points here. So let's investigate this real quick. What is this? What's the deal with the rho and pi and the z? And you have this radian and degree. So radian and degree, you must be dealing with some kind of circle or something that's kind of like involving sine functions. Radian degree. So we have cylinder and spherical. Basically, if you we try the rho seems to be like, if you imagine a circle, rho is like the radius, I think. The pi is the one that's rotate. So if I'm doing it really slowly, you can see that's the phi going around, and then the rho is kind of like extending out. So if I draw, kind of imagine we have like a cylinder. My guess with this node is that that is the rho, and the one that goes around is the pi, and then we have the z, of course, going up. So that's the z. Same deal, I think my guess is with the vector polar. For the sphere here, we have the rho going up and down in the sphere. Okay, interesting. Rho. So that's the rho, and then there's a phi. Phi didn't do anything unless maybe I use the theta. So the theta, there's the phi. So the rho, the phi seems to be doing something. The rho is affected by phi and theta. So spherical is a bit more confusing to explain, I guess. But I'll start with a cylinder and maybe switch to spherical at some point. Okay, rho phi z. Okay, let's see. Perhaps we can zero out everything and then give it a value of rho. And phi, okay, the phi is going around, so we can use the phi and the z, I think, with a range float. Let's try this real quick. Supposedly we have like how many points? 10 points or 30 points. And we plug in the points into the z. Okay, we have something that looks like lines. That's cool. How about the phi? Okay, the phi, if I increase the phi, you see it's keep going, it's doing this rotations kind of thing, which means maybe I can plug this into the phi and I get a spiral, because this is kind of like a, for every points we input into this vector polar input, it's gonna kind of like growing, and then it's you can imagine it like it might have some kind of influence or kind of like a field in the like a cylinder in this case. So it's going that like that in a spiral kind of motion, and we can of course increase or decrease the resolutions of the points using the count. Okay, that's pretty clear. How about the other guy, the spherical? This might be similar, but I don't know. The phi and the theta. Okay, the phi and the theta, we quickly get something that's, okay, we have like a number 8. Why is that? I don't know the answer, but that's interesting. There's probably there's some kind of sine or cosine underneath there. I can try something. Let's see the row. Maybe I turn off the theta and then I actually get a circle, which is fancy, but okay, so just now I was doing this theta thing, and then it seems to be like going from the top to the bottom. So you see, this is like minus. Let's try from 0. So 0 is at 0, 0, 0, and then it grows until around 2 point somethings. Because it's currently using radian, and with radian, the value goes from, I think, what's the number? I think pi is a 3.14. 2 pi is like a full circle, and it's just around 6.28 around. But the radian, I always forget about radian. Maybe we just use degree, and then so now we can have something that grows in degree, kinda. But that means our start and stop here should be like 360. Okay, that's a full circle. 0 to 360. Maybe we have a little bit over. Anyway, this is the theta. Okay, going from 0 to 360. What if we have like a bunch of this theta? 0 to 360 count. This thing I can understand, but maybe I need to use another of this guy and then plug it in. Okay, that's it's starting to looks like a sphere. This is gonna be a little bit difficult to explain, kind of like a trial and error thing, but yeah, just imagine it. There's like a field, like a spherical field here, and then there's a cylindrical field over here. So basically, if you can imagine a cylinder and then make a point to go around the cylinder, you can use this vector polar input. Makes me wonder if we okay, there's this node called UV connection that's it can be used in conjunction with this vector polar input. With UV connection, it's easy for you to get a line. Currently, it's by default it's creating polygon, but you want the edges, so you have now spiral. Slice on and off doesn't matter in this case, but so we can control the row, so we can control the details of the phi and the z. You can of course separate this phi and the z, and then you might get something that's even more interesting. Something like that. If we make the row getting smaller, for example, let's see what happens if we. Oh, okay, this one going larger, so we have like something that looks like a typhoon. This is also pretty useful. It's probably if you are like a technical artist, you know, if you learn programming, it's maybe this is something that you will encounter at some point. So you can control all this, which is pretty cool. If we maybe with the row, if we use like a math sign into it, seems to be broken, but not. Oh, I need to just to update it. So I'm using a sign in a row, and we start to get a interesting kind of pattern, or interesting like a line doing funky stuff. It's a little bit like using the super formula. With super formula, you're dealing with a lot of maths, but with this three angles, rho, phi, and theta, you can end up with a lot of interesting looking curve. And with UV connection, you get this line edges. Of course, you can bake it. It's easy. You can also use the polyline viewer. This is also really handy. The polyline viewer will output curve objects. And if you use B-spline, it's gonna smooth the lines. Looks very nice that way. And of course, this is already like real objects in Blender. You can use a funky matcat. Let's save this and file save again as new blend file. So yeah, what else we can do with this? I can increase the sine frequency, and then, well, that's you get a coil there. That's also accidental. I don't know how I get there, but it's pretty cool. This coil, maybe the start and stop can increase. Oh yeah, that's super interesting and unpredictable. You sort of understand, okay, what's going on, but not really obvious at first. Hey, is that? See if I make this like 360. I'm using like the radian here. Maybe if I turn it to degree means I need like a bigger number here. 720 here. See all kind of weird pattern that's hard to explain. Something I don't know. Radian works better somehow. Yeah, end up with something that looks like flower. How did I create that? It's pretty interesting. Yeah, I guess we can leave that like that. How about this, the spherical? Polyline viewer. Let's turn it off. Plug this in. Okay, so that's our sphere. Have not touched the row. I can zero out the row, but the row seems to be controlling the radius of the sphere. I can slice it. Here's having like a range float inside the range float is sometimes just give like a surprise, interesting surprise. Because basically, because this is a Sverchok and you're having like multiple range float like this, generate like a bunch of lists, and then so we have like multiple lines inside this vector polar input. So yeah, I cannot explain what's going on here, but I think you just need to try it. You might end up with a pattern that's totally out of, you know, like looks, it's gonna look beautiful, but it's surprisingly, you didn't expect it. You're gonna get, you don't know the outcome, you know, just keep trying and make something. I think I can also use the row. Just plug into the row and what? That's the other guy. So that's plugging this thing into the row. Count. If someone asks you, okay, how did you create it? I don't know this. If you print it out, maybe this can make a nice earrings. Step. Whoa. Count. Maybe give a map function sign. Update it. 10. Increase number. No. See, I don't know how to explain that, but it looks kind of interesting. Multiply the frequency. 10. Update. Yeah, so that's a similar kind of pattern. If you have a particle and then you have some kind of random field, that's probably what you will get. Yeah, I don't know, I think that's for you to try. If let's try another thing real quick. Compositing. If we have Suzanne or let's try with Torus and stretch of new objects in, and then the polar output in this case. Plug in the vector in there. Now we have the rho and phi and the z. Rho, phi, and z, and then we need to probably need the other polar. So I don't know what's the results gonna be, but let's have a look. Rho, phi, and z. Get our object. Nothing seems. Nothing much seems to be happening. Maybe. Okay. Maybe use math and update. Okay, that's doing that. Multiply. Okay, that's kind of like squeezing the torus in this case. How about the phi? The phi seems to be like rotating each and every point there. Interesting. How about the z? Okay, it's like pushing the points in the vertically. Not too interesting. Polar out. Do I still have this? Okay. Box, vector, and add. Add. Okay, add. Not so interesting. How about the sphere? Sphere is slightly more interesting. And if we don't use the torus, if we use something like Suzanne or Teapot, get selection. Let's zero all this. Well, we have actually quite unusual. It's don't know what's going on, but it seems to be kind of slicing this teapot. Very interesting. How about the ad? Okay, the ads just pushing teapot, and this one is kind of It's as if the teapot is going through the kind of like a glass like that. I think that's what it's doing. If we use cylinder, yeah, it's like being pushed inside the cylinder and then out again. Funny thing is, it's called cube push up. Maybe it's as if the cube going through the sphere. Maybe. Okay, let's try one last thing. It's just a cube, and subdivide this many times. So cube, load the cube, and sphere, and sphere. What do we get? So that's controlling the radius of this cube being pushed. You might think that it's similar to projection, but not really. This is doing more than that. That's a sphere and this is cylinder. Maybe if we use like a certain number in a 5, for example, maybe if I use range, I can kind of twist this guy. Yeah, I think that's my guess is correct. It's twisting this guy right here, but not too much. Maybe with the right number. If I subdivide this more and reload, kind of twisting it. Expanding it smaller. Yeah, it's a little bit weird. Okay, I'm doing range float over another range float. I probably like duplicating this guy over this guy, and I might have like 40,000 objects at this moment. I'm still calculating. Yeah, well, that's anyway, just like a quick explorations of the vector polar in and polar out nodes in SphereChalk. It's a weird node, but you can create like a very funky looking curve using these nodes, simply and thinking in terms of spherical and cylindrical. Okay, that's it's done calculating. I might have done something really bad here. There's a lot of vertices. Okay. We might need like multiple edge poly here. We have 4. Okay, it says. But I think it's just a matter of experimentations at this point. But like I said earlier, I made this DNA kind of looking. Where is it? It's a polar test. Polar test. Yet polar test file. Save as. This is. I'll just save it as Sverchok DNA. This can be another live noding, but I think I'm not gonna do that. Here's the setup. Okay, it's not overly complicated. It's basically what I did at the very end. After the vector polar stuff, I kind of separate the points and extend the points, extend the edges, and then separate the line here so they become like a pair. I'm using list masking and UV connections, and in the end I end up with this. I use this polyline viewer, so I have something that looks like a DNA, but at the beginning it's it's similar to what I did earlier. So just experimenting with this with the polar thing. I think I'm using the cylinder. See, cylinder. There's a sine wave, and yeah, there's a start and the end here, and multiplier. This is the number of points, but I end up with like a DNA strand. What's interesting here is, of course, the lines. It's remember how let me draw it real quick. Turn off only render and world background off. Remember, we can create a spiral very easily. If you have two spiral and you connect points, you can end up with a DNA strands. In here, I'm using this this technique that I kind of figure out earlier. It's kind of a way to separate all the edges and then extend it. Let's say if you have like a square like this, there's some kind of Sverchok magic here, so we can separate all the lines and then randomize the lines, and we have something that looks like this, kind of the being extended out, the edges being extended out and then separated, so we have like a stick. This is probably something that I will kind of demo at some point. It's how I did the Pocky Sticks thingy. Let me quickly. Oh, maybe it's not here. Where is it? The Pocky Stick. Pocky Stick. There you go. Pocky Monkey. This is something that I use. I created using this Sverchok setup where I separate all the edges and then extend it out. I will probably show the making of this at some point, but at the moment I'm still kind of testing this setup and replacing the Pocky Stick with other things like maybe matches or pencil or chopsticks or bamboo. But anyway, that's for another live noding. Just keep you kind of curious. Try this vector polar node anyway, and yeah, let's see what you can come out with. Thanks again for tuning in to this live noding video. I'll see you in the next video. Leave a comment if you have any question, and subscribe to the channel so I can make more video like